Hi everyone, welcome to this video. We will explore the concept of kinematics, specifically about uniformly accelerated motion in AS level physics. My name is Toni Hidayat and I will be guiding you through this topic, all aligned with topic 2, subtopic 2.1, learning objective number 6 to 9 of the Cambridge syllabus for the examination in 2025 to 2027. Let's get started. The sixth learning objective is derived from the definitions of velocity and acceleration, equations that represent uniformly accelerated motion in a straight line. In this section, we'll derive the equation for motion in a straight line under uniform acceleration. Take the example of a meteor entering Earth's atmosphere, accelerating due to gravity. From the definition of velocity and acceleration, we can derive four essential kinematic equations. The first one is from the definition of acceleration. Acceleration equals to change in velocity over time taken. If we expand the change in velocity, it becomes final velocity minus initial velocity. And then we move the time to the left side, so we will get this form of equation. And then when we modify again, we will get this one. Final velocity equals to initial velocity plus acceleration times time. And then for the second one, we get from this displacement equals to average velocity times time. And then when we expand the average of velocity, it becomes final velocity plus initial velocity divided by 2 times time, of course. And then for the third one, we get it from the second equation. But here, we try to expand the v based on what we get from the first equation. The v here is u plus at. And then we simplify. So we got this. And then we simplify again by opening the bracket. So this is the third equation in kinematic. Displacement equals to initial velocity times time plus half times acceleration times time square. And then for the last one, it's also from the second one, but now we substitute or expand the time. The time will be equals to final velocity minus initial velocity over acceleration. And then we simplify this, it will be quadratic equation like this. And then we modify, it will be like this by moving the 2a to the left side. And then we just rearrange by moving the minus u squared to the other side. So this is the final form for the fourth equation in kinematic. Final velocity square equals to initial velocity square plus 2 times acceleration times displacement. And this is the explanation for each symbol we have in this four equation. As for displacement, the unit will be in meter. U is initial velocity. The unit will be meter times second to the power of -1. V is for final velocity. The unit will be meter second to the power of -1. And then A is acceleration. The unit is meter times second to the power of -2. And T is for time. The unit is second. The seventh learning objective is solve problems using equations that represent uniformly exerted motion in a straight line, including the motion of bodies falling in a uniform gravitational field without a resistance. Now let's apply these equations. The first example is about uniformly exerted motion in horizontal. This is the example of problem. An aircraft starting from rest accelerates uniformly along a straight runway. It reaches a speed of 200 km per hour and travels a distance of 1.4 km. What is the acceleration of the aircraft along the runway? First, we may listing down what we know from the question. We know u is 0 km per hour. How do you know? Because here we have a statement starting from rest. Rest, it means the velocity equals to 0. And then for the v final velocity is 200 km per hour. It's very clear written in the question. And then s is the displacement or distance equals to 1.4 kilometer, and it's also written clearly in the question. And then here we have to find the acceleration or a. Based on what we know from the question, we know UVS and we are going to find dA, so we may use this equation. V square equals to U square plus 2AS. And then we may substitute the V. It's 200 square equals to the U is 0. So U is 0, yes, 0 square plus 2A times the displacement or distance 1.4. And then 200 square is 40,000. 0 square is 0. So 2 times 1.4 is 2.8A, and the A will be 40,000 divided by 2.8. So the final answer will be 1.4 times 10 to the power of 4 kilometer per hour square. Let's examine vertical motion. This is an example of uniformly exerted motion in a vertical direction. The example of the problem is: a boy stands on a cliff edge and throws a stone vertically upwards at time t equals to 0. The stone leaves his hand at 20 meters per second. Take the acceleration of the ball as 9.81 meters per second square. You may assume the boy's hand does not move vertically after the ball is released. Calculate the time taken for the stone return to the level of the boy's hand. First, we may list down what we know from the question. We know the u is 20 meters per second, and then the g here is negative since the motion of the object is going upward, meanwhile the g is downward. So the g is negative 9.81 meters per second square. And here we are going to find the t, or time. And then we have to understand that the object actually has two stages of motion. First, when the stone is going upward, and the second one when the stone is going back downward. When the stone is moving upward, so the final velocity will be 0 at the highest point of the motion. So we may use this equation to find the time from when the boy released the stone until it reached the highest point. V equals to U plus AT. V is the 0, and then u is the initial velocity 20, and then a is negative 9.81 times t. And then we may move the negative 9.81 t to the left side, and then we find the t, or time, will be equals to 0.49 seconds. So the time taken for the stone to reach the highest point when it's thrown up is 0.49 seconds. And then please also understand that the time taken from the highest point to the level of the boy's hand will be similar, because here we ignore the air resistance. So when the stone is moving downward, the time will be the same. So in total, the time will be 2 times the time that we just get. 2 times 0.49, which is 0.98 seconds. The egg learning objective is describe an experiment to determine the acceleration of free fall using a falling object. How can we experimentally determine the acceleration of free fall or the acceleration due to gravity? We can use a setup where a ball bearing is held by an electromagnet. When released, it falls onto a trapdoor, starting and stopping a timer. By knowing the height and the time it takes for the ball to fall, we can calculate the acceleration due to gravity using the following equation. Because here the initial velocity is 0, so u will be 0 times t will be also 0. And then we got this, and then we modify this equation to find the g. G will be equals to 2h over t squared. So the h here, before we start the timer, we can measure what is the height, and then the time is from the timer, and then when we calculate we will get the g. Of course, to make the g is more precise, we can do this experiment more than one, let's say 10 times, so we can get the average, so the result will be more precise. The ninth learning objective is describe and explain motion due to a uniform velocity in one direction and a uniform acceleration in a perpendicular direction. The learning objective basically discusses the projectile motion. For an object launched at an angle, its motion in the horizontal direction is uniform motion. Its motion in the vertical direction is uniformly exerted by gravity. First, how to find the time taken to reach the maximum height. So here we have an object with the initial velocity to this direction. It makes an angle of theta to the horizontal. So the trajectory or the path will be parabolic like this because the u is not aligned with x nor y axis, so it has ux equals to u cosine theta, and also it has uy equals to u sine theta. Because here we assume that there is no air resistance, and then we take the g is 9.81 meter per second square. So at the highest point, the velocity in x will be the same as the initial because there is no force that can reduce the acceleration. So at this point, the vx will be the same as ux, which is u cosine theta. However, the Vy will be 0. Why? Because from this point to this point, the object is moving upward, meanwhile the G will be downward in opposite direction. So it will make the velocity in Y direction, it becomes 0. Okay, and then when it reach the same level as the beginning, the V here will be the same as this, will be the same as U. And also for the um, vector component will be the same as before here. Now, and then how to find the time? Now here we are going to only analyze in y-axis. We may use this one, v equals to u plus 80. Remember, we only analyze in y-axis. So v will be 0 here. We only analyze from starting to the highest point. And then du will be u sine theta from here. Okay, and then minus g. Why it's minus? Because once again, at this moment from this to this, the object is moving upward, meanwhile the g is. To calculate the maximum height reached by the projectile, so here the same object that has the initial velocity u to this direction, and then the same theta to the horizontal. So the trajectory will be parabolic like this. So the uy will be u sine theta as before, and here we ignore air resistance, and the g is still the same, 9.81 meter per second square. So at the top here, at the highest point, the vy will be 0. And then here we are going to find the maximum height. How? We may use the equation, and we still analyze in y-axis. In y-axis, v square equals to u square plus 2as. And then we substitute from the value we know here. The v here is 0. By the way, we analyze from beginning here until it reach the highest position, yeah. So the v is 0, yeah. Here is 0 squared will be still 0, and then u here is the initial velocity in y direction. It will be u sine theta, so u sine theta square. And then minus 2g, minus is coming from the g because once again the g and the motion of the object at this moment in opposite direction. Yeah, the motion is going upward, meanwhile the g is downward, so that's why here we have minus from the g. And then we open the bracket, so it will be u square sine square theta, and then we modify, we got this, and then we modify again to find the maximum height. The maximum height will be equals to u square sine square theta over 2g. Finally, let's calculate the horizontal range of the projectile motion. Since there is no horizontal acceleration, the horizontal velocity remains constant. Okay, let's understand again the situation. Here we have an object with the velocity u to this direction with the angle theta to the horizontal. So the trajectory of the motion will be like this. And then in x-axis, the u will be u cosine theta. Okay, once again, no air resistance, and the g 9.81 meter per second square. And then at this point, the vy equals to 0. And then at this point, the vx will be the same as before because why? Because there is no force that will decrease the velocity since we ignore the air resistance. So We already get before that the time taken for the beginning until it reached the highest position will be this u sine theta over g. And then the time from the highest position until it reached the same level as the beginning, it will be the same as before, u sine theta over g. So the total time from beginning until the end here will be 2 u sine theta over g. So we are going to find the range. It means the length from beginning here in horizontal until this point. How? So we are going to analyze in x-axis. Yeah, because in x-axis is a uniform motion. So the equation is relatively simple. Only displacement equals to velocity times. And then in this case, the distance is r, yeah, from this point to this point. And the v will be the same as velocity in x-axis. It means u cosine theta. And then for the time will be from here to u sine theta over g. And then here we try to modify by times u times u. So we have u square, and then we rearrange the position. We put 2 here, and then here we have 2 sine theta cosine theta. It's actually the same as sine to theta. So that's why the range will be initial velocity square times sine to theta over g. That concludes our discussion on uniformly exerted motion in AS level physics. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more physics content. Also remember to follow us on Instagram @pengajarfisika for more updates and learning resources. Thanks for watching, and I will see you in the next video.